If we were to condense Earth's timeline into one 24-hour day, mankind would only be on Earth for approximately 3 seconds. But when exactly did our universal clock start, and how was it set into motion in the first place? Today, I will explain exactly how everything began and how we came to be where we are today. Before the Big Bang Theory, everything is thought to have existed on a subatomic level, with our little speck starting out far smaller than an atom, which is about 0.1 to 0.5 nanometers. Then everything set into motion when all matter in the universe came into existence in an instant, about 14 billion years ago. One very small and very dense speck was the start of everything. Once the Big Bang Theory happened, everything was very heated, with a temperature of approximately 1 billion degrees for the first 10 seconds. Then the universe began rapidly cooling and expanding, faster than the speed of light. Light is our window into the past, and astronomers can use light to see the history of the Big Bang Theory. In fact, the light you see today from the star Andromeda is approximately 2.5 million years old, so each time you see a star in the sky, you're looking into the past. The very first light in the universe was between 240,000 and 300,000 years. This point in our timeline is called the era of recombination. Everything truly started to form when tiny vibrating strings of energy made quarks, and quarks became protons, which are positively charged particles, and neutrons, which are neutral particles. Then electrons, which are negatively charged particles, became trapped in orbit around nuclei. Once this happened, it took 380,000 years before the first atoms were formed. Once atoms came into existence, elements began to form. The first two elements were hydrogen and helium. Together, these two elements were the main building blocks of the universe. Once the universe cooled enough, gravity began to form and create the first stars, the oldest of which is Methuselah, aged at approximately 13.6 billion years old. Our solar system began approximately 5 billion years ago with a cloud of stellar dust. The first celestial body in the Milky Way galaxy to form was the Sun. The formation of the Sun used most of the material in the stellar cloud as well. The Sun formed from the fusion of hydrogen and helium and the release of their energy. The Sun was alone in our galaxy, and it wasn't until 4.5 billion years ago that Earth joined the Milky Way galaxy. Our entire solar system has a total of 1 star, 5 dwarf planets, 8 planets, and an approximate 193 moons. The major planets are divided into 2 categories, terrestrial and Jovian. The Jovian planets are characterized by their gaseous composition, which is primarily hydrogen and helium, strong magnetic fields, many moons, rings, and low density. The 4 Jovian planets are Jupiter, Saturn, Uranus, and Neptune. The terrestrial planets are the closest to the Sun and are characterized by their small mass, high density, and primarily solid composition. The 4 terrestrial planets are Mercury, Venus, Mars, and Earth. Earth wasn't always the cool and nurturing planet we now know it as, but rather it began as a hot and inhospitable planet. Then, early in its development, Earth collided with another massive celestial object known as Theia. The collision caused parts of Earth to break off and spew into the solar system. It was from this chaos that our moon was formed. The moon is the 5th largest satellite in the entire solar system, and its radius is approximately 1,079.4 miles, sitting at approximately 238,900 miles from the Earth. The moon is the Earth's only natural satellite. The moon is also tide-locked with Earth. Thus, it is always showing us the same face. We also know that as time goes on, the moon is getting further and further away from the Earth. Our Earth is still hot, but its heat is primarily within its core. Earth is made up of 4 layers: the solid inner core, which is believed to be iron, and the liquid outer core, which is thought to be a combination of nickel and iron. The lower mantle, the upper mantle, and the crust. The upper mantle can be further divided into what we call the asthenosphere and the lithosphere. However, the lithosphere is part of the crust. The lithosphere is rigid, brittle, and relatively resistant to deformation. The asthenosphere is essentially solid rock. However, It is so close to melting point that it contains pockets of molten lava and is relatively plastic. In its early years, the Earth's surface was also different. Thanks to Alfred Wegener, we now know about continental drift. About 200 million years ago, Earth had a giant supercontinent known as Pangaea. Over the years, it rifted, and parts began to drift. Right around 3.5 billion years ago, the first life form appeared, and it is through biological evidence, the continuity of geological features, and glacial evidence that we are able to prove Pangaea. With each passing day, we find more fossils of species long past, and it is actually not until around 300,000 years ago that Homo sapiens first appeared, and our 3 seconds began. However, as we go through history, animal species weren't the only things that evolved. Minerals have also evolved. In the beginning, it is believed that the Earth only had a few mineral species. Yet, as animal diversity increased, so did mineral diversity. It is believed that as animals evolved, minerals did too. With our knowledge of Earth and its many processes, now we can watch our Earth and see the many different ways minerals and rocks form, and how processes like weathering break down rock on the Earth's surface. Now, as we all know, Earth is ever changing and moving. Well, so is our universe. Thanks to the blue tint of light we can see, we know that our universe is still expanding. However, it's also slowing down. Furthermore, we can see through the use of thermodynamics that our future may end in the death of heat variation, which would be the end of our story. However, there are also things like the Big Crunch theory that predict how our story will end. Today, we may know the story, and yet tomorrow we may know nothing.